Question 1. Which of the following is equivalent to sine squared 5x? Sine squared 5x can be expressed in terms of cos squared 5x using the Pythagorean identity sine squared theta plus cos squared theta equals 1, where theta is equal to 5x. Rearranging the Pythagorean identity to make sine squared theta the subject of the formula, we have sine squared theta is equal to 1 minus cos squared theta. Therefore, the answer is option B. Question 2. The probability distribution table for a discrete random variable x is shown. What is the expected value of x? One way to answer this question is to use the stat mode on your calculator. So press mode, stat, and 1 var, so number 1, and just make sure that the frequency column is enabled. So what I'll do is I'll type in the first column, so 1, 2, 3, so they're the scores, and then the probability that those scores will occur. So 0.6, 0.3, and 0.1. And press AC, shift 1, and then number 4 var, and then number 2 x bar to get the expected value, and the answer is 1.5, so option C. Another way of finding the expected value of x is to add an xpx column to this table. That's like adding an fx column to a frequency distribution table, where you would have the scores, that's x, and then the frequency, which is f. So you'd have an fx column here. This works in a similar way. So adding an xpx column is calculated the same way as an fx column. So we take the score and then multiply it by the probability of that score occurring. So 1 multiplied by 0.6 is 0.6. 2 multiplied by 0.3 is equal to 0.6. And 3 multiplied by 0.1 is 0.3. And then we take the sum of that column, and that's equal to 1.5. Therefore, the answer is option C. Question 3. Which of the following represents the domain of the function f of x equals ln of 1 minus x? The input to a logarithm function must be positive. Hence, 1 minus x is greater than 0. Solving this inequality for x, we can add x to both sides. We get 1 is greater than x. And rearranging the inequality so that the variable is on the left-hand side, x is less than 1. In interval notation, that's open bracket, negative infinity, comma 1, close open bracket. The answer is option D. Question 7. The number of downloads of a song on each of 20 consecutive days is shown in the following graph. Which of the following graphs best shows the cumulative number of downloads up to and including each day? Looking at the graph that shows the number of downloads per day, the minimum number of downloads occur at day 1 and day 20, and the maximum number of downloads occur at day 10. So we would expect that in the cumulative frequency graph, the change in height between the consecutive days should be minimal between days 1 and 2 and days 19 and 20, and maximum between days 9, 10 and 11. And the option that shows that is option C. So we can see that between days 1 and 2, the change is minimal there. Between days 19 and 20, the change in height is minimal there. But in days 9, 10 and 11, that's where you get the greatest change. So the answer is option C. Question 10. Which of the following best represents the graph of y equals 10 multiplied by 0.8 to the power of x? Two things to consider. Firstly, the y-intercept. We have a choice of 10 or 8. So to find the y-intercept, let x equal 0. So when x equals 0, y equals 10 multiplied by 0.8 to the power of 0, and 0.8 to the power of 0 is equal to 1, and that equals 10. So the two options at the moment are either A or C. So B and D are out. Next, consider the value of the base. Now, because the base is between 0 and 1, this is a decreasing exponential graph going from left to right. So therefore, out of A or C, option A shows a decreasing exponential graph with a y-intercept of 10. So therefore, the answer is option A. Question 11. There are 8 chocolates in a box. 3 have peppermint centers, P, and 5 have caramel centers, C. Kim randomly chooses a chocolate from the box and eats it. Sam then randomly chooses and eats one of the remaining chocolates. A partially completed probability tree is shown. What is the probability that Kim and Sam choose chocolates with different centers? This is a multi-stage event without replacement. In the first stage, there are 8 chocolates to choose from, 3 of which are peppermint, 5 of which are caramel. So the probability of choosing peppermint is 3 out of 8, and the probability of choosing caramel is 5 out of 8. In the second stage, there are 7 chocolates to choose from. The probability of choosing peppermint, given peppermint was chosen first, is 2 out of 7. The probability of choosing caramel, given peppermint was chosen first, is 5 out of 7. The probability of choosing peppermint, given caramel was chosen first, is 3 out of 7. And the probability of choosing caramel, given caramel was chosen first, is 4 out of 7. Now we're interested in the probability that the 2 chocolates chosen were of different centers, and that can occur in any order. So the 2 outcomes that we're interested in is peppermint caramel or caramel peppermint. So the probability of peppermint then caramel is 3 out of 8 multiplied by 5 out of 7, which equals 15 out of 56. And the probability of caramel then peppermint is equal to 5 out of 8 multiplied by 3 out of 7, which equals 15 out of 56. So the probability that the 2 chocolates chosen were of different centers is equal to the sum of these 2 probabilities. So that's equal to 15 out of 56 plus 15 out of 56, which equals 30 out of 56, and that simplifies to 15 out of 28. So therefore the answer is option D. Question 7. The diagram shows part of y equals f of x, which has a local minimum at x equals -2 and a local maximum at x equals 3. Which of the following shows the correct relationship between f double dash of -2, f of 0, and f dash of 3? F of 0 corresponds to the y coordinate at the point where x equals 0, and it's negative. And I've just made that point here. F dash of 3 is the gradient of the tangent at the point where x equals 3, which is this point here. We can see here that this is a stationary point, so f dash of 3 is equal to 0. F double dash of 2 represents the second derivative, and it's at a point where the curve is concave up, which means that f double dash of 2, or the second derivative at x equals 2, is positive. Therefore, the answer is option A. F of 0 is less than f dash of 3, which is less than f double dash of -2. Question 8. The graph of y equals f of x is shown. Which of the following could be the equation of this graph? This is a graph of a polynomial of degree 4. There's a simple 0 at x equals -1, and the shape of the curve around that point resembles a linear function with a positive gradient. There's a triple 0 at x equals 2, and the shape of the curve around that point represents a cubic curve that's been reflected in the y-axis and then translated 2 units to the right. Also, as x approaches infinity, y approaches negative infinity, and as x approaches negative infinity, y approaches negative infinity. And that can be seen by observing the arrows here and here. Therefore, the answer is option C. Question 9. Let h of x equals f of g of x, where the function f of x is an odd function and the function g of x is an even function. The tangent to y equals h of x at x equals k, where k is greater than 0, has the equation y equals mx plus c. What is the equation of the tangent to y equals h of x at x equals -k? Firstly, the composition of an odd function and an even function in any order results in an even function. This means that the tangent at x equals negative k is a reflection of the tangent y equals mx plus c in the y-axis. And this is done by replacing the x with negative x. So f of x is equal to f of negative x for an even function. Therefore, the answer is option B. Question 10. The line y equals mx is a tangent to the curve y equals cos of x at the point where x equals a, as shown in the diagram. Which of the following statements is true? The coordinates of the point of contact of the tangent y equals mx and the curve y equals cos of x is a, cos of a. That's this point here. Notice that this point occurs before the stationary point where x equals 2 pi. Hence, a is less than 2 pi. Taking the reciprocal of both sides, reversing the inequality symbol, we get 1 over a is greater than 1 over 2 pi, or 1 over 2 pi is less than 1 over a. The next point to consider is that cos of a is approximately equal to 1, but a is less than 2 pi. Now the gradient m is equal to cos of a over a, so that's the y coordinate over the x coordinate, rise over run. Hence, m is greater than 1 over 2 pi. The last point to consider is that cos of a over a is less than 1 over a, since a is less than 2 pi, and cos of 2 pi is approximately equal to 1. So in an inequality, if the denominators are equal, but the numerator, or one numerator, is slightly less than the other numerator, so cos of a is ever so slightly less than 1, cos of a over a, or m, is less than 1 over a. Hence, the answer is option B. Question 29. Solve x plus x minus 1 over 2 equals 9. The first step is to eliminate the fraction by multiplying every term by 2. It helps to enclose the numerator in its own set of brackets. Now x multiplied by 2 is 2x. X minus 1 all over 2 multiplied by 2 is x minus 1, and they're enclosed in brackets. 9 multiplied by 2 is 18. Next, expand the brackets. And there's not much that needs to be done there apart from just removal of the brackets. So 2x plus x minus 1 is equal to 18. Collecting the like terms, 2x plus x is 3, and adding 1 to both sides, 18 plus 1 is 19. Finally, dividing both sides by 3, we have x is equal to 19 over 3. Now we can check the solution by substituting 19 over 3 for x in the left-hand side of the equation. So checking the left-hand side equals 9. 19 over 3 plus 19 over 3 minus 1 all over 2. Evaluating that expression does equal 9, which equals the right-hand side. So we are confident that this is, in fact, the correct answer. Question 32. A right-angled triangle XYZ is cut out from a semicircle with center O. The length of the diameter XZ is 16 centimeters and angle YXZ is equal to 30 degrees, as shown in the diagram. Part A. Find the length of XY in centimeters, correct to 2 decimal places. In right-angled triangle XYZ, XY is the adjacent side to angle theta, and XZ is the hypotenuse. Using right-angle trigonometry, that means cos of 30 degrees is equal to XY divided by 16. That's adjacent over the hypotenuse. Multiplying both sides by 16 to make XY the subject of the formula, we have 16 multiplied by cos of 30 degrees is equal to XY. Evaluating the left-hand side, we have 16 multiplied by cos of 30 is equal to 13.8564, and so on. And rounding this value to 2 decimal places, XY is equal to 13.86 centimeters. Part B. Hence, find the area of the shaded region in square centimeters, correct to 1 decimal place. To work out the area of the semicircle, we need the radius of the semicircle first. The diameter is 16 centimeters and the radius is half the diameter. So the radius of the semicircle is 8 centimeters. Now the area of the semicircle is given by the formula half multiplied by pi r squared, where r is 8 centimeters. So that's equal to half multiplied by pi multiplied by 8 squared, and that equals 100.5309649 square centimeters. The area of triangle XYZ is found using the area rule for triangles. That's half AB multiplied by sine C. So that's equal to half multiplied by 13.86 multiplied by 16 multiplied by sine of 30 degrees. And that's equal to 55.44 square centimeters. The area of the shaded region is the difference between the area of the semicircle and the area of the triangle. So that's equal to 100.5309649 minus 55.44, and that's equal to 45.0909649, and rounding this value to one decimal place, that's equal to 45.1 square centimeters. Question 13. Find the exact gradient of the tangent to the curve y equals x multiplied by tan of x at the point where x equals pi over 3. Differentiate y equals x multiplied by tan of x using the product rule, since x multiplied by tan of x involves a product of two functions in x. So by the product rule, y dash is equal to u dash v plus uv dash, where u is equal to x, u dash is equal to 1, v is equal to tan x, and v dash is equal to sec squared x. Hence, y dash equals f dash of x equals tan of x plus x multiplied by sec squared of x, and sec squared of x is 1 over cos squared of x. And we'll use that in the next step, which is to find the exact gradient by substituting x equals pi over 3 into the first derivative. So f dash of pi over 3 is equal to tan of pi over 3 plus pi over 3 multiplied by 1 over cos squared pi over 3. And tan of pi over 3 is the square root of 3. And 1 over cos squared pi over 3 is 4. So f dash of pi over 3 is equal to square root of 3 plus pi over 3 multiplied by 4, which equals square root of 3 plus 4 pi over 3. Question 14. The first term of an arithmetic sequence is 5. The sum of the first 43 terms is 2021. What is the common difference of the sequence? The strategy applied here involves two steps. The first step is to find the value of L, which corresponds to the last term of this partial arithmetic series, or the 43rd term, and then taking that value and applying the formula for the general term of an arithmetic sequence, and then solving for D, which is the common difference. So that's the formula Tn is equal to A plus n minus 1D. So let's find the value of L first, or T43. So Sn, or the sum to n terms, is equal to n over 2 multiplied by A plus L. N is equal to 43, so that's the number of terms in this partial series. And S43, so the sum of the first 43 terms is 2021, and the first term, A, is equal to 5. So solving for L, we have 2021 is equal to 43 over 2 multiplied by 5 plus L, and then multiplying both sides by 2 and dividing both sides by 43, we have 2021 multiplied by 2 divided by 43 is equal to 5 plus L. And then making L the subject of the formula by subtracting 5 from both sides, we have L is equal to 2021 times 2 divided by 43 minus 5. L is equal to 89, which corresponds to T43, or the 43rd term, is equal to 89. Now let's apply this formula. Tn is equal to A plus n minus 1D. We know what the 43rd term is now. It's equal to 89. We know what the first term is. That's 5, so A is equal to 5. And we know that n is equal to 43. So solving for D, we have 89 is equal to 5 plus 43 minus 1 times D. 84 is equal to 42 times D, so subtracting 5 from both sides, we get 84. And then dividing both sides by 42, we have D is equal to 84 divided by 42, and therefore D equals 2. Hence, the common difference is 2. Question 15. Evaluate the definite integral from x equals negative 2 to x equals 0 of the square root of 2x plus 4 dx. Firstly, we'll express the integrand using index notation. So the square root of 2x plus 4 is written as 2x plus 4 to the power of half. Now we can integrate this expression. So the integral from negative 2 to 0 of 2x plus 4 to the power of half, add 1 to the index, then we divide by the new index and then divide by the derivative of 2x plus 4. So this equals 2x plus 4 to the power of 3 over 2 divided by 3 over 2 divided by 2 from negative 2 to 0. Now note that dividing by 3 over 2 and then dividing by 2 is equivalent to multiplying by 2/3 and then multiplying by half, which is the same as multiplying by 1/3. So applying the limits, we have 1/3 multiplied by, in square brackets, 2 multiplied by 0 plus 4 to the power of 3 over 2 minus 2 multiplied by negative 2 plus 4 to the power of 3 over 2. Note that 2 multiplied by negative 2 is negative 4. Negative 4 plus 4 is 0, of course. 0 to the power of 3 over 2 is 0. And 2 times 0 is 0 plus 4. That's 4 to the power of 3 over 2 is just 4 to the power of 3 over 2. Now 4 to the power of 3 over 2 is equivalent to 4 multiplied by the square root of 4. So we have 1/3 multiplied by 4 multiplied by the square root of 4, and of course that's 2. And evaluating that expression, that equals 8 over 3 or 2 2/3. Question 16. For what values of x is f of x equals x squared minus 2x cubed increasing? F of x is a polynomial of degree 3, and the graph is a cubic curve. There's a double zero at x equals 0, and a simple 0 at x equals half. And here's a sketch of the graph. This will help us to visualize what the solution may look like. Now, the graph is clearly increasing from the origin up to the stationary point here at point A, and point A is between 0 and half. So this gives us an idea of what the solution may look like. Now the graph is increasing when the first derivative, f dash of x, is greater than 0. So differentiating f of x, so f dash of x is equal to 2x minus 6x squared, and solving for f dash of x greater than 0, 2x minus 6x squared is greater than 0. Dividing both sides by 2, we have x minus 3x squared is greater than 0. Now we're going to use a table of sines to determine the values of x for which x minus 3x squared is greater than 0. Now x minus 3x squared equals 0 has zeros at x equals 0 and x equals 1/3. So using a table of sines, so first row is x and the second row is f dash of x, so the value of the first derivative at the particular values of x that we've chosen. 0 and 1/3 are the values of x where f dash of x is equal to 0. Now when x equals negative 1, f dash of x is negative 4, so clearly that's not part of the solution. When x equals 1/4, so we've just chosen a value between 0 and 1/3. F dash of x is equal to 1 over 16, that's positive, so that's clearly in the solution set. And just choosing x equals 1, so just beyond 1/3, f dash of x, or f dash of 1, is equal to negative 2, so that's outside the solution set. So f dash of x is greater than 0 for values of x between 0 and 1/3. So therefore, f of x is increasing for values of x greater than 0 and less than 1/3. Question 33. For a sample of 17 inland towns in Australia, the height above sea level, x meters, and the average maximum daily temperature, y degrees Celsius, were recorded. The graph shows the data as well as a regression line. The equation of the regression line is y equals 29.2 minus 0.011x. The correlation coefficient is r equals negative 0.494. Part A, I. By using the equation of the regression line, predict the average maximum daily temperature in degrees Celsius for a town that is 540 meters above sea level. Give your answer correct to 1 decimal place. Substituting x equals 540 into the equation of the regression line, y equals 29.2 minus 0.011 multiplied by x, y is equal to 29.2 minus 0.011 multiplied by 540, and that equals 23.3 degrees Celsius, correct to 1 decimal place. Part A, II. The gradient of the regression line is negative 0.011. Interpret the value of this gradient in the given context. Interpreting the value of this gradient in the given context, for every 1 meter increase in height above sea level, the average maximum daily temperature drops by 0.011 degrees Celsius for heights within the range of data specified. Part B. The graph below shows the relationship between the latitude, x degrees south, and the average maximum daily temperature, y degrees Celsius, for the same 17 towns, as well as a regression line. The equation of the regression line is y equals 45.6 minus 0.683x. The correlation coefficient is r equals negative 0.897. Another inland town in Australia is 540 metres above sea level. Its latitude is 28 degrees south. Which measurement, height above sea level or latitude, would be better to use to predict this town's average maximum daily temperature? Give a reason for your answer. Comparing the correlation coefficients for latitude and height above sea level, it would be better to use latitude since its correlation coefficient of r equals negative 0.897 is strong, compared with the correlation coefficient for height above sea level, which is r equals negative 0.494, indicating a moderate correlation. Question 37. The diagram shows a triangle ABC where AC equals 25 centimetres, BC equals 16 centimetres, angle BAC equals 28 degrees, and angle ABC is obtuse. Find the size of the obtuse angle ABC, correct to the nearest degree. There is a known angle side pair, so the sine rule will be used. Sine of B over 25 is equal to sine of 28 degrees over 16. Multiplying both sides by 25 to make sine of B the subject of the formula, we get sine of B is equal to 25 multiplied by sine of 28 degrees over 16. Taking the inverse sine of both sides to make angle B the subject of the formula, we get acute angle B is equal to inverse sine of 25 multiplied by sine of 28 degrees over 16. And that equals 47 degrees and 11 minutes, correct to the nearest minute. To obtain obtuse angle ABC, we subtract 47 degrees and 11 minutes from 180 degrees. So obtuse angle B is equal to 180 degrees minus 47 degrees and 11 minutes, and that equals 132 degrees and 49 minutes, which rounds to 133 degrees, correct to the nearest degree. Question 19. Without using calculus, sketch the graph of y equals 2 plus 1 over x plus 4, showing the asymptotes and the x and y intercepts. The graph is a hyperbola with a vertical asymptote at x equals negative 4 and a horizontal asymptote at y equals 2. The vertical asymptote occurs because x cannot equal negative 4, and the horizontal asymptote occurs because as x approaches infinity or negative infinity, the fractional component of the equation approaches 0. So the graph approaches y equals 2. Now to find the y-intercept, we let x equals 0. Substituting x equals 0 into the equation, we get y equals 2 plus 1 over 4. Hence the y-intercept's equal to 9 over 4. So I've left that as an improper fraction. Now to find the x-intercept, we let y equals 0. So 0 equals 2 plus 1 over x plus 4. And solving for x, we get 1 over x plus 4 is equal to negative 2. Taking the reciprocal of both sides, we get x plus 4 is equal to negative 1/2. And subtracting 4 from both sides, we get x equals negative 4 minus 1/2. Hence, the x-intercept is equal to negative 9 over 2. Putting all that together, here's the graph of the hyperbola, here's the horizontal asymptote, vertical asymptote, y-intercept, and the x-intercept clearly labelled. Question 20. For what values of x in the interval x greater than or equal to 0 and less than or equal to pi over 4 does the line y equals 1 intersect the graph of y equals 2 sine 4x? Solve for x the equation 2 multiplied by sine of 4x is equal to 1. Dividing both sides by 2, we have sine of 4x is equal to half, and we'll call that equation number 1 for reference. The domain of x is x greater than or equal to 0 and less than or equal to pi over 4. Hence, the domain of 4x is greater than or equal to 0 and less than or equal to pi. From equation number 1, sine of 4x is equal to half. Taking the inverse sine of both sides, we have 4x is equal to inverse sine of half. Hence, 4x is equal to pi over 6 or 5 pi over 6, since this solution lies in this domain. Making x the subject of the formula by dividing both sides by 4, we have x is equal to pi over 24 or 5 pi over 24. Therefore, the line y equals 1 intersects the graph of y equals 2 sine of 4x at x equals pi over 24 and 5 pi over 24 in the interval x greater than or equal to 0 and less than or equal to pi over 4. Question 21. Consider the graph of y equals f of x as shown. Sketch the graph of y equals 4 f of 2x, showing the x-intercepts and the coordinates of the turning points. The function is in the form y equals k multiplied by f of a outside of x plus b plus c, with k equals 4, a equals 2, b equals 0, and c equals 0. Next, we follow DRT, which means we consider the dilations first, then the reflections, and then the translations for horizontal transformations and then for vertical transformations. Given that b equals 0 and c equals 0, there's no translations. And given that k and a are both positive, there's no reflections either. Now, k equals 4 and a equals 2 means that there's a vertical dilation and there's a horizontal dilation. Now, a equals 2 implies that there's a horizontal compression by factor 2. And k equals 4 means there's a vertical stretching by factor 4. So when a equals 2 and there's a horizontal compression by factor 2, that means the x coordinates are divided by 2. K equals 4 means that the y coordinate, or any of the y coordinates on the curve, are multiplied by 4. Putting all that together, the sketch of the transformed curve may look something like this. The origin has not been transformed at all, since dilating the origin just results in the origin itself. Horizontally dilating the stationary point, so that's 4, negative 8. The 4 is divided by 2, but the negative 8 is multiplied by 4. And we end up with this point here. And the x-intercept of 6, its y-coordinate is 0, so there's no vertical dilation there, obviously. But the x-coordinate, or the x-intercept, is divided by 2. So we end up with an x-intercept of 3 in the transformed curve. Question 22. A random variable is normally distributed with mean 0 and standard deviation 1. The table gives the probability that this random variable lies between 0 and z for different values of z. The probability values given in the table for different values of z are represented by the shaded area in the following diagram. Part A. Using the table, find the probability that a value from a random variable that is normally distributed with mean 0 and standard deviation 1 lies between 0.1 and 0.5. The probability that z lies between 0.1 and 0.5 is equal to the probability that z lies between 0 and 0.5 minus the probability that z lies between 0 and 0.1. And from the table, the probability that z lies between 0 and 0.5 is 0.1915, and the probability that z lies between 0 and 0.1 is 0.0398. And the difference between the two is 0.1517. Part B. Birth weights are normally distributed with a mean of 3,300 grams and a standard deviation of 570 grams. By first calculating a z-score, find how many babies, out of 1,000 born, are expected to have a birth weight greater than 3,528 grams. Firstly, we'll calculate the z-score that corresponds to a birth weight of 3,528 grams. Using the z-score formula, that's 3,528 minus the mean of 3,300 in brackets divided by the standard deviation of 570, and that equals 0.4. Now the probability that z is greater than 0.4 is equal to 0.5 minus the probability that z lies between 0 and 0.4, and that equals 0.5 minus 0.1554, and that value can be found by using the z-score table, and that equals 0.3446. Now the relative frequency, so the number of babies born out of 1,000 that have a birth weight greater than 3,528 grams, is equal to 1,000 multiplied by 0.3446, which equals to 344.6, and rounding down to the nearest whole number, that's equal to 344. So therefore, 344 out of 1,000 babies born are expected to have a birth weight greater than 3,528 grams. Question 23. A population, P, which is initially 5,000, varies according to the formula P equals 5,000 multiplied by B to the power of negative T over 10, where B is a positive constant and T is time in years, where T is greater than or equal to 0. The population is 1,250 after 20 years. Find the value of T, correct to one decimal place, for which the instantaneous rate of decrease is 30 people per year. The first step is to find the value of B. The population is 1,250 when T equals 20 years. Substituting these two values into the formula, we have 1,250 is equal to 5,000 multiplied by B to the power of negative 20 over 10. Dividing both sides by 5,000 and evaluating the index, we have 1 over 4 is equal to B to the power of negative 2. And expressing the right hand side with a positive index, we have 1 over 4 is equal to 1 over B squared, and therefore B equals 2. The next step is to find the value of t when dp dt is equal to negative 30. Now dp dt is equal to 5,000 multiplied by 2 to the power of negative t over 10 multiplied by the derivative of the index, which is negative 1 over 10, multiplied by ln of 2, which equals negative 500 ln of 2 multiplied by 2 to the power of negative t over 10. Let dp dt equal negative 30. So negative 30 is equal to negative 500 ln of 2 multiplied by 2 to the power of negative t over 10. We're going to solve for t. And 3 over 50 ln of 2 is equal to 2 to the power of negative t over 10. So that's dividing both sides by negative 500. Now before we take the log of both sides, you can see that the right hand side is a reciprocal. So just to make life a little bit easier, I'm going to take the reciprocal of both sides. So 50 ln of 2 over 3 is equal to 2 to the power of t over 10. So this negative index has now become a positive index. Now taking the log of both sides, and I've chosen the natural logarithm, the ln. So ln of 50 ln of 2 over 3 is equal to ln of 2 to the power of t over 10. So I'm going to use one of the logarithm laws to bring t over 10 to the front. So ln of 50 ln of 2 over 3 is equal to t over 10 multiplied by ln of 2. Multiplying both sides by 10 and dividing both sides by ln of 2 to make t the subject of the formula, we have 10 over ln of 2 multiplied by ln of 50 ln of 2 over 3 equals t. And evaluating the left-hand side, that equals 35.301, and so on. Therefore, the instantaneous rate of decrease of 30 people per year occurs at a time t equals 35.3 years, correct to one decimal place. Question 24. The curve y equals 3 over x minus 1 intersects the line y equals 3 over 2 multiplied by x at the point 2, 3. The region bounded by the curve y equals 3 over x minus 1, the line y equals 3 over 2 multiplied by x, the x-axis, and the line x equals 4 is shaded in the diagram. Find the exact area of the shaded region. The area of the shaded region is given by the area of the triangle from x equals 0 to x equals 2 plus the area under the curve y equals 3 over x minus 1 from x equals 2 to x equals 4. Now the triangle has a base of 2 and a height of 3. So the area is half multiplied by 2 multiplied by 3. And the area under the curve y equals 3 over x minus 1 from x equals 2 to x equals 4 is equal to 3 multiplied by the integral from x equals 2 to x equals 4 of 1 over x minus 1 dx. And that equals 3 plus 3 multiplied by ln of x minus 1 from x equals 2 to x equals 4. Applying the limits, we have 3 plus 3 multiplied by ln of 3 minus ln of 1, and ln of 1 is 0. And that equals 3 plus 3 multiplied by ln of 3 square units. Question 40. A table of future value interest factors for an annuity of $1 is shown. Simone deposits $1,000 into a savings account at the end of each year for 8 years. The interest rate for these 8 years is 0.75% per annum, compounded annually. After the 8th deposit, Simone stops making deposits but leaves the money in the savings account. The money in her savings account then earns an interest at 1.25% per annum, compounded annually for a further 2 years. Find the amount of money in Simone's savings account at the end of 10 years. The solution is split into 2 parts. In the first part, we'll determine the amount of money in the account at the end of 8 years using the table of future value interest factors. The result of which is fed into the second part of the solution, which uses the future value formula to find the value in the account at the end of 10 years. So in the first 8 years, there are 8 deposits made at 0.75% per annum compounded annually. So the correct future value interest factor is 8.2132. So row 8 and column 0.75%. So the amount of money at the end of 8 years is 8.2132 multiplied by 1,000, since that's the value of Simone's contribution, and that equals $8,213.20. Now the amount of money at the end of 10 years, we have n equals 2, since it's 2 more years after the 8 years. The present value is taken from the result of the first part of the solution, which is $8,213.20. So that's how much Simone has in the account at the start of the 2 years where she's not making any deposits. And the interest rate per annum is 1.25%. So the future value is equal to $8,213.20 multiplied by 1 plus 1.25%, all raised to the power of 2. And that equals 8,419.8133 and so on. So rounding that to 2 decimal places, Simone will have $8,419.81 in her savings account at the end of 10 years. Question 26. A particle is shot vertically upwards from a point 100 meters above ground level. The position of the particle, y meters above the ground after t seconds, is given by y of t equals negative 5t squared plus 70t plus 100. Part A. Find the maximum height above ground level reached by the particle. The function y of t that represents the position of the particle is a concave down parabola because the degree is 2 and the leading coefficient is negative. Hence, the maximum height corresponds to the vertex of this parabola. To find the x-coordinate of the vertex, we use the formula x equals negative b over 2a, and the independent variable in this context is t. So t equals negative 70 over negative 10. Hence, the maximum height occurs at time t equals 7 seconds. So to find the height at time t equals 7 seconds, we substitute 7 into this equation. So y of 7 is equal to negative 5 multiplied by 7 squared plus 70 multiplied by 7 plus 100, and that equals 345 meters above the ground. Part B. Find the velocity of the particle in meters per second immediately before it hits the ground, leaving your answer in the form a square root of b, where a and b are integers. The time when the particle hits the ground is found by solving y of t equals 0. In other words, negative 5t squared plus 70t plus 100 equals 0. Dividing both sides by negative 5, we have t squared minus 14t minus 20 equals 0. Solving for t by completing the square, we add 20 to both sides and then halve the negative 14 and square it and then add that to both sides as well. So we have t squared minus 14t plus 49 is equal to 20 plus 49. The left-hand side is a perfect square and that can be factorized as such. So t minus 7 all squared is equal to 69. Taking the square root of both sides, we have t minus 7 is equal to plus or minus the square root of 69. Hence t is equal to 7 plus or minus the square root of 69. But t is greater than or equal to 0 since it represents time. So therefore, the time when the particle strikes the ground is t equals 7 plus the square root of 69 seconds. Now the velocity v of t is found by differentiating negative 5t squared plus 70t plus 100, which is the position of the particle. V of t is equal to negative 10t plus 70. When t is equal to 7 plus the square root of 69, v of t is equal to negative 10 outside of 7 plus the square root of 69 plus 70. Expanding the brackets, we have negative 70 minus 10 square root of 69 plus 70. So the negative 70 and the positive 70 cancel. Therefore, the velocity of the particle when it strikes the ground is negative 10 square root of 69 meters per second. Question 27. Kenzo has a solar-powered phone charger. Its power, P, can be modelled by the function P of t equals 400 sine pi over 12t, where t is greater than or equal to 0 and less than or equal to 12, where t is the number of hours after sunrise. Part A. Sketch the graph of P for t greater than or equal to 0 and less than or equal to 12. The period is 2 pi divided by pi over 12, which equals 24, and the amplitude is 400. This is a sine curve that's been stretched horizontally as well as vertically, but it hasn't been translated or reflected. Now we're sketching the graph for values of t from 0 to 12, which is half of the period. Here is a sketch of the graph, so it's half of a sine curve, with the peak occurring at t equals 6. Power is the rate of change of energy. Hence the amount of energy, E units, generated by the solar-powered phone charger from t equals A to t equals B, where A is greater than or equal to 0 and less than or equal to B, and B is less than or equal to 12, is given by E equals the integral from A to B of P of t dt. Part B. Show that E equals 4,800 over pi multiplied by cos of A pi over 12 minus cos of B pi over 12. E equals 400 multiplied by the integral from t equals A to t equals B of sine of pi over 12t dt. And that equals 400 multiplied by negative cos of pi over 12t multiplied by 12 over pi from t equals A to t equals B. This multiplication by 12 over pi can be taken outside of the square brackets since 12 over pi is a constant. And that equals 4,800 over pi multiplied by negative cos of pi over 12t from t equals A to t equals B. Applying the limits of integration, we have 4,800 over pi multiplied by negative cos of pi over 12b minus negative cos of pi over 12a, and of course a minus minus becomes a positive or becomes a plus, and that equals 4,800 over pi multiplied by cos of pi over 12a minus cos of pi over 12b as required. Part C. To make a phone call, a phone battery needs at least 300 units of energy. Kenzo woke up 3 hours after sunrise and found that his phone battery had no units of energy. He immediately began to use his solar-powered charger to charge his phone battery. Find the least amount of time he needed to wait before he could make a phone call. Give your answer correct to the nearest minute. Solve for B the equation 4,800 over pi multiplied by cos of pi over 12a, where a equals 3, minus cos of pi over 12b is equal to 300. Dividing both sides by 4,800 over pi and evaluating pi over 12 multiplied by 3, we have cos of pi over 4 minus cos of pi over 12b is equal to pi over 16. Now cos of pi over 4 is equal to root 2 on 2. And we're going to multiply both sides of the equation by negative 1, which makes the equation a little bit easier to solve. So cos of pi over 12b minus root 2 on 2 is equal to minus pi over 16. Adding root 2 on 2 to both sides, we have cos of pi over 12b is equal to root 2 on 2 minus pi over 16. Taking the inverse cos of both sides, we have pi over 12 multiplied by b is equal to inverse cos of root 2 on 2 minus pi over 16. Therefore, b is equal to inverse cos of root 2 on 2 minus pi over 16 divided by pi over 12, which equals 3.95238 and so on, hours, and converting that into hours and minutes, that equals 3 hours and 57 minutes. Now to find the charging time, which is the amount of time that Kenzo has to wait, of course, charging time is 3 hours and 57 minutes minus 3 hours is equal to 57 minutes. So therefore, Kenzo will need to wait at least 57 minutes before he could make a call. Part D. The next day, Kenzo woke up 6 hours after sunrise and again found that his phone battery had no units of energy. He immediately began to use his solar-powered charger to charge his phone battery. Would it take more time or less time or the same amount of time compared to the answer in Part C to charge his phone battery in order to make a phone call? Explain your answer by referring to the graph drawn in Part A. It would take less time. The graph peaks at t equals 6 and is significantly higher than at t equals 3. Hence, to get 300 units of energy, the area under the curve will have a narrower width from t equals 6 compared to t equals 3 hours. Question 28. The region bounded by the graph of the function f of x equals 8 minus 2 to the power of x and the coordinate axes is shown. Part A. Show that the exact area of the shaded region is given by 24 minus 7 over ln of 2. The curve intersects with the x-axis at x equals 3, since 8 minus 2 to the power of 3 equals 0. The area is the integral from x equals 0 to x equals 3 of 8 minus 2 to the power of x dx, and that equals 8x minus 2 to the power of x over ln of 2 from x equals 0 to x equals 3. Applying the limits of integration, we have 8 multiplied by 3 minus 2 to the power of 3 over ln of 2 minus 0 multiplied by 3 minus 2 to the power of 0 over ln of 2, and 2 to the power of 0 is 1, and that equals 24 minus 8 over ln of 2 plus 1 over ln of 2, which equals 24 minus 7 over ln of 2 as required. Part B. A new function, g of x, is found by taking the graph of y equals negative f of negative x and translating it by 5 units to the right. Sketch the graph of y equals g of x, showing the x-intercept and the asymptote. Negative f of negative x rotates a curve 180 degrees about the origin. In this case, negative f of negative x is equal to negative outside of 8 minus 2 to the power of negative x. To translate this curve 5 units to the right, we subtract 5 from x. So y is equal to negative outside of 8 minus 2 to the power of negative outside of x minus 5. Now expanding the brackets, we have g of x is equal to 2 to the power of 5 minus x minus 8. And here is a sketch of the graph of 2 to the power of 5 minus x minus 8. We have a y-intercept of 24, an x-intercept of 2, and the asymptote y equals negative 8. Part C. Hence, find the exact value of the integral from x equals 2 to x equals 5 of g of x dx. The area is identical in magnitude to Part A, but opposite in sign. Hence, the exact value is 7 over ln of 2 minus 24. Question 29, Part A. On the day that Megan was born, her grandfather deposited $5,000 into an account earning 3% per annum compounded annually. On each birthday after this, her grandfather deposited $1,000 into the same account, making his final deposit on Megan's 17th birthday. That is, a total of 18 deposits were made. Let AN be the amount in the account on Megan's nth birthday after the deposit is made. Show that A3 equals $8,554.54. This may be answered recursively. A0 equals $5,000, and that represents the amount that Megan has in her account on the day she was born. A1 is equal to 5,000 multiplied by 1.03 plus 1,000, and that equals $6,150. A2 is equal to $6,150 multiplied by 1.03 plus 1,000, and that equals $7,334.50. A3 is equal to $7,334.50 multiplied by 1.03 plus 1,000, and that equals $8,554.535, rounding that to two decimal places. That equals $8,554.54 as required. Part B. On her 17th birthday, just after the final deposit is made, Megan has $30,025.83 in her account. You are not required to show this. Megan then decides to leave all the money in the same account, continuing to earn interest at 3% per annum compounded annually. On her 18th birthday, and on each birthday after this, Megan withdraws $2,000 from the account. How many withdrawals of $2,000 will Megan be able to make? The first step is to find a non-recursive formula that represents the amount of money in Megan's account after n withdrawals of $2,000. Let P equal $30,025.83, R equals 1.03, and M equals $2,000. Now A1 represents the amount of money in Megan's account after her first withdrawal of $2,000, and that equals PR minus M. A2 is equal to A1 multiplied by R minus M, where A1 is equal to PR minus M. And expanding the brackets, we have PR squared minus MR minus M. A3 is equal to A2 multiplied by R minus M, where A2 is equal to PR squared minus MR minus M. And expanding the brackets, we have PR cubed minus MR squared minus MR minus M. And we can generalize a formula from this. We have AN, so the amount of money in Megan's account after n withdrawals of $2,000 is equal to PR to the power of n minus M outside of 1 plus R squared plus ... plus R to the power of n minus 1. Now here we have a geometric progression. And this is a sum of a geometric progression or a geometric series. And this can be represented by the formula 1 minus R to the power of n over 1 minus R. So AN is equal to PR to the power of n minus M outside of 1 minus R to the power of n over 1 minus R. The next step is to solve for n the equation AN equals 0. That is PR to the power of n minus M outside of 1 minus R to the power of n over 1 minus R equals 0. Multiplying both sides, or all sides in fact, by 1 minus R, we have PR to the power of n multiplied by 1 minus R minus M outside of 1 minus R to the power of n equals 0. Now we have values for P, R, and M, and they've been substituted here. And I've moved this negative 2,000 over to the other side for the next line, and also factorized out R to the power of n, knowing that we're going to use logarithms later on to make n the subject of the formula. And we end up with this line here where we have 1.03 to the power of n is equal to this expression here. Applying logarithms to both sides to make n the subject of the formula, we have n multiplied by ln of 1.03 is equal to ln of this expression. And dividing both sides by ln of 1.03, we have n is equal to 20.249. So in other words, Megan can make 20.249 withdrawals, but that doesn't make any sense. It needs to be an integer, of course. So we're going to round down to the nearest integer. So Megan can make 20 whole withdrawals of $2,000. Question 30. The number of hours for which light bulbs will work before failing can be modeled by the random variable x with cumulative distribution function f of x equals 1 minus e to the power of negative 0.01x for x greater than or equal to 0, or f of x equals 0 for x less than 0. Jane sells light bulbs and promises that they will work for longer than exactly 99% of all light bulbs. Find how long, according to Jane's promise, a light bulb bought from her should work. Give your answer in hours, rounded to two decimal places. X represents the number of hours a light bulb works for, and f of x represents the percentage of all light bulbs that have a working life up to and including x hours. Now, Jane sells light bulbs and promises that they will work for longer than exactly 99% of all light bulbs. So we're going to solve for x the equation 1 minus e to the power of negative 0.01x equals 0.99. So rearranging this formula to make x the subject of the formula, we have negative e to the power of negative 0.01x equals 0.99 minus 1. Multiplying both sides by negative 1, we have e to the power of negative 0.01x equals 1 minus 0.99. Evaluating the right-hand side, we have e to the power of negative 0.01x equals 0.01. Taking the natural log of both sides, we have negative 0.01x equals ln of 0.01. Dividing both sides by negative 0.01, we have x is equal to 460.5170186, and rounding that value to 2 decimal places, x is equal to 460.52. So therefore, a light bulb bought from Jane should last at least 460.52 hours. Question 31. By considering the equation of the tangent to y equals x squared minus 1 at the point a, a squared minus 1, find the equations of the two tangents to y equals x squared minus 1 which pass through 3, negative 8. The gradient of the tangent to the parabola y equals x squared minus 1 at x equals a can be found by finding the first derivative, so dy dx is equal to 2x, which is equal to f dash of x, and then substituting x equals a into the first derivative. So f dash of a is equal to 2a. Now the gradient of the tangent can be defined in another way. The gradient of the tangent passes through the point a, a squared minus 1, as well as the point 3, negative 8. So using the gradient formula, y2 minus y1 over x2 minus x1, the gradient of the tangent is equal to a squared minus 1 minus negative 8 over a minus 3, and that equals the gradient of the tangent found by using the first derivative. So that equals 2a. Now we need to solve this equation for a. So multiplying both sides by a minus 3, we have a squared plus 7 is equal to 2a squared minus 6a, and this plus 7 arises from this negative 1 minus 8. And that equals a squared minus 6a minus 7 equals 0 if we move everything to one side and form a quadratic equation. And factorising this quadratic equation, we have a minus 7 multiplied by a plus 1 is equal to 0. So therefore, a is equal to negative 1 or 7. Now the equation of the tangent passing through 3, negative 8, we can use the point gradient formula. That's the y minus y1 equals m outside of x minus x1 formula. And we have two cases. So case 1, a is equal to negative 1. We have y plus 8 is equal to 2a outside of x minus 3, but a is equal to negative 1, so 2 times negative 1 is negative 2. So y plus 8 is equal to negative 2 outside of x minus 3. And expanding the brackets, we have y plus 8 is equal to negative 2x plus 6, and therefore y is equal to negative 2x minus 2. If we move this positive 8 over, it becomes negative 8. So y is equal to negative 2x minus 2. Now, case 2, we have a equals 7, and we just repeat the same process as case 1. So y plus 8 is equal to 2a outside of x minus 3, but a is equal to 7, so 2 times 7 is equal to 14. Y plus 8 is equal to 14 outside of x minus 3. Expanding the brackets, we have y plus 8 is equal to 14x minus 42. Subtracting 8 from both sides, we have y is equal to 14x minus 50. So therefore, the equations of the tangents to the parabola y equals x squared minus 1 passing through 3, negative 8, y equals negative 2x minus 2, and y equals 14x minus 50. Question 41. In a particular city, the heights of adult females and the heights of adult males are each normally distributed. Information relating to two females from that city is given in Table 1. The means and standard deviations of adult females and males in centimetres are given in Table 2. A selected male is taller than 84% of the population of adult males in this city. By first labelling the normal distribution curve below with the heights of the two females given in Table 1, calculate the height of the selected male in centimetres, correct to 2 decimal places. By the empirical rule, a female of height 175 centimeters is 2 standard deviations above the mean, and a female of height 160.6 centimeters is 1 standard deviation below the mean. There are 3 standard deviations in between 160.6 and 175. The standard deviation of the female population, sigma f, is equal to 175 minus 160.6, so that's the difference between these two heights, divided by 3. So sigma f is equal to 4.8 centimeters. Mu f, or the mean of the female population, can be found by taking 160.6 and adding 1 standard deviation to that value. So 160.6 plus 4.8 is equal to 165.4 centimeters. Referring to table 2, the mean of the male population is equal to 1.05 multiplied by 165.4, which equals 173.67 centimeters. And the standard deviation of the male population is equal to 1.1 multiplied by 4.8, which equals to 5.28 centimeters. By the empirical rule, a male taller than 84% of the population of adult males has a z-score of positive 1. Therefore, the height of the selected male is the mean of the male population plus 1 standard deviation, which equals 178.95 centimeters. Question 33. People are given a maximum of 6 hours to complete a puzzle. The time spent on the puzzle in hours can be modelled using the continuous random variable x, which has probability density function f of x equals ax over x squared plus 4 for x greater than or equal to 0 and less than or equal to 6, where a is greater than 0, and f of x equals 0 for all other values of x. The graph of the probability density function is shown below. The graph has a local maximum. Part A. Show that a equals 2 over ln of 10. F of x is a probability density function. That means the area under the curve y equals f of x from x equals 0 to x equals 6 equals 1. Hence, the integral from x equals 0 to x equals 6 of ax over x squared plus 4 dx equals 1. And we need to solve this equation for a. Now a is a constant, and that can be taken outside the integral. Multiplying the x by 2 will make the numerator a derivative of the denominator, hence the integral will involve a logarithm. But we need to compensate for this multiplication by 2 by multiplying the integral by half on the outside. Now integrating 2x over x squared plus 4, that's equal to ln of x squared plus 4 from x equals 0 to x equals 6, and multiplying by half a on the outside, and that equals 1. Applying the limits of integration, we have half a multiplied by ln of 40 minus ln of 4 equals 1. And note that ln of 40 minus ln of 4 is equal to ln of 40 over 4. So that's from one of the logarithm laws, and that's equal to ln of 10. So we have half a multiplied by ln of 10 equals 1, multiplying both sides by 2 and dividing both sides by ln of 10, we have a is equal to 2 over ln of 10 as required. Part B. Show that the mode of x is 2 hours. The mode is the x-coordinate of the local maximum. So to find that, we need the first derivative. Now using the quotient rule, f dash of x is equal to u dash v minus uv dash over v squared, where u equals ax, u dash equals a, v is equal to x squared plus 4, and v dash is equal to 2x. Now we need to solve for x, the numerator equaling 0. So that's the only way a fraction can equal 0 is if the numerator equals 0. So u dash v minus uv dash equals 0. We have a outside of x squared plus 4 minus 2a multiplied by x squared equals 0. And since a is a non-zero constant, we can divide all terms by a. So we have x squared plus 4 minus 2x squared equals 0. Collecting the like terms and subtracting 4 from both sides, we have negative x squared is equal to negative 4. So therefore, x equals 2. Therefore, the mode of x is 2 hours as required. Part C. Show that the probability that the random variable x is less than 2 is equal to log base 10 of 2. The probability that x is less than 2 is given by the integral from x equals 0 to x equals 2 of f of x dx. From part B, the probability that x is less than 2 is equal to half multiplied by 2 over ln of 10 multiplied by ln of 8 minus ln of 4 in brackets. Now half multiplied by 2 over ln of 10 is equal to 1 over ln of 10, and ln of 8 minus ln of 4, using one of the logarithm laws to simplify this, is equal to ln of 8 over 4. And that equals ln of 2 over ln of 10, and from the change of base rule, that equals log of base 10 of 2 as required. Part D. The intelligence quotient, IQ, scores of people are normally distributed with a mean of 100 and a standard deviation of 15. It has been observed that the puzzle is generally completed more quickly by people with a high IQ. It is known that 80% of people with an IQ greater than 130 can complete the puzzle in less than 2 hours. A person chosen at random can complete the puzzle in less than 2 hours. What is the probability that this person has an IQ greater than 130? Give your answer correct to 3 decimal places. Firstly, the z-score corresponding to an IQ of 130 may be found using the z-score formula. And that's 130 minus 100 divided by 15, and that equals 2. Now, the probability that someone chosen has an IQ of greater than 130 is equal to the probability that the z-score is greater than 2. And by the empirical rule, that equals 0.025. Now, the probability that someone chosen has an IQ of less than or equal to 130 is the complement of 0.025, which is 1 minus 0.025, which equals to 0.975. This step here is not necessary for this solution, but it's provided for completeness. Now, from part C, the probability that x is less than 2, that is, someone chosen completes a puzzle in less than 2 hours, is equal to log base 10 of 2. Hence, the probability that someone chosen has an IQ of greater than 130 and completes the puzzle in less than 2 hours is equal to 0.025 multiplied by 0.8, which equals to 0.02. Now, this two-way table is not necessary for this solution, but again, it's provided for completeness. Now, the probability that someone chosen has an IQ of greater than 130, given that they've completed the puzzle in less than 2 hours, is equal to 0.02 divided by log base 10 of 2, which equals to 0.066438, and so on, and rounding this value to 3 decimal places, that equals 0.066. Question 34. A discrete random variable has probability distribution as shown in the table, where n is a finite positive integer. Show that the expected value of x is equal to n outside of. The expected value of a discrete probability distribution is found by summing the product of each score with its respective probability. So in this case, the expected value of x is equal to r multiplied by r to the power of n. So that's the product of the terms in the first column, plus r squared multiplied by r to the power of n minus 1. So that's the score in the second column multiplied by its respective probability, and so on. And there are n terms to sum here. So simplifying all this, we end up with the expected value of x is equal to n multiplied by r multiplied by r to the power of n. Since we can use basic index laws to express each of these terms in terms of r and r to the power of n. So r squared multiplied by r to the power of n minus 1, if you add the indices, that's r to the power of n plus 1, which is just r multiplied by r to the power of n. Hence why we come up with this equation here. The expected value of x is equal to n multiplied by r multiplied by r to the power of n. Now, the next point to note is that being a discrete probability distribution, the sum of the probabilities, so that's the sum of the second row in that table, must equal 1. And so the terms in the second row are r plus r squared plus r cubed plus dot 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 plus r to the power of n. So these are the probabilities in the second row, and they must sum to 1 for a valid discrete probability distribution. Now, this happens to be a geometric progression. First term is r and a common ratio of r, and the sum of n terms is equal to 1, being a discrete probability distribution. So using the sum to n terms of a geometric progression formula, that's the Sn equals a outside of 1 minus r to the power of n over 1 minus r, and just substituting in r for a as the first term, and a common ratio of r, and the sum to n terms is equal to 1, we have 1 equals r outside of 1 minus r to the power of n over 1 minus r. So that's the sum of the p x equals x row. And we'll call that equation number 2. So what we're going to do is then equate equations 1 and 2 together and make e of x, or expected value of x, the subject of the formula. So from equation number 1, I've rearranged this equation slightly. So e of x, or expected value of x, over nr is equal to r to the power of n. So I want to eliminate this r to the power of n term, because in the end, the answer is in terms of 2r or 2r minus 1. There's no r to the power of n. And we're going to sub this into equation number 2 for r to the power of n. So we're going to replace this term here, r to the power of n, with ex over nr. And so from equation number 2, and I've multiplied both sides by 1 minus r as well. So we have 1 minus r is equal to r outside of 1 minus expected value of x over nr. So 1 minus r is equal to r minus expected value of x over n. So that's multiplying through by r. We're expanding the brackets here. So this r and this r here will cancel. And then multiplying all terms by n to eliminate the fraction, we have n minus nr is equal to nr minus e of x, expected value of x. And I've just reversed the terms. So ex minus nr is equal to nr minus n. So I've also flipped sort of each side of the equation around just to make ex the subject, or eventually it will be. And then adding nr to both sides, we end up with expected value of x is equal to 2nr minus n. And then factorizing out the n, we have expected value of x is equal to n outside of 2r minus 1 as required.